Good day, dear audience. My name is Anastasiia Kiian. I represent Karaz in Kharkiv National University, and today I would like to present to you the results of our study on the topic data hiding scheme based on spread sequence addressing. For further consideration of the topic, first of all, it is necessary to give a definition of steganography. There are various computing techniques to transmit secret messages. For example, cryptographic techniques hide the semantic content of transmitted messages, presenting them in the form of noise-like minor data. In its turn, steganographic techniques hide the existence of information messages. In this case, messages are hidden inside cover files using redundant data. Today, steganographic methods are very well developed. The literature describes various ways of hiding information messages in images, sound, text documents, video, etc. The most common examples are described for cover images. But it's worth noting that the most promising direction in data hiding is spread spectrum steganography. These techniques use the advance in sophisticated discrete signals theory to provide broadband and high-speed digital communications. For example, modern 4G and 5G mobile communication systems use broadband signals, providing high noise immunity, safety, and environmental friendliness of communication. These positive properties can also be used to hide data inside cover files, for example, in images. It should be noted that the introduction of new technologies for hiding data creates additional risks for computer security, for example, through the possible introduction of malicious computer programs. In this sense, the development and research of modern data hiding techniques is especially relevant, including in the context of ensuring the cybersecurity of critical information systems. We propose the technique for hiding data in cover images using direct spread spectrum. We show that some of the basic assumptions and hypotheses adopted for broadband high-speed digital communication may not be met when data is hidden within cover files. This leads to negative effects. First of all, cover files are heavily distorted, and secondly, error rate in the recovered messages is so high. Because of this, we propose a new technique that implies directly address the propagation sequence. It significantly reduces cover file distortion. At the same time, the error rate in covered messages doesn't increase. We give the illustrative examples and show the advantages of the proposed method. Popular examples of spread spectrum steganography use pseudo-random sequences to hide messages. In this case, various data can be used as cover files, images, audio, video, etc. In addition, hiding can be implemented both in the spatial domain and in the DCT domain. We will now focus on this, since the method proposed below can also be applied in various ways. To describe the basic technology, we will follow the publications of different authors, nevertheless offering some of our interpretations. Let's designate an information message as bit sequence M with index E, written in polar form. Discrete signals in this case are used to implement direct spectrum technology, and they are written as phi with index I from K to N. Moreover, each signal is a pseudo-random sequence. It is assumed that different signals from the set phi are weakly correlated, so the coefficient of their cross-correlation is approximately 0. The stego file S is formed by adding an amplified modulated signal E to the original file C. In such case, big G is higher than 0, and it is a gain factor that sets the energy of the modulated signal E. The restoration of the information messages on the receiving side is carried out using correlation reception. It is assumed that each signal from the set phi is not correlated with the original cover file C. In such case, the value of the correlation coefficient is defined as follows, accepting the assumption which was fixed earlier. So according to such calculation, the result sequence is formed as follows. Certain bit e is equal to -1 if rho is lower than 0 and 1 if rho is higher than 0. Obviously, the total number key of hidden information bits cannot be large. Indeed, if key is equal to 1, then the cover file will not be significantly disturbed. We can note that cover file C distortion will be in the range from -G to G. If G is not big, then S approximately equal to C. For example, for cover images, distortion will not be visually noticeable. However, with increasing value of key, the distortion of the cover file increases proportionally and it is in the range from -G product key and 2G key. For example, we also designate information message as a bit sequence M written in polar form. Hiding the message is performed in blocks of k bits. For convenience, we represent the information message as a sequence of non-negative integers. These integers will be interpreted as addresses, ordinal numbers of pseudorandom sequence. To reduce the distortion of the cover file, we propose to hide information messages based on the addressing of the spreading sequences. The spreading sequence encoding rule is proposed to be implemented as follows. That is, modulation is carried out through addressing the signals in set phi. The proposed approach minimizes the introduced distortions of the cover file used. Indeed, the cover file is formed as before by the element-wise addition of the modulated signals and the cover data instead of the previous example. And now we have that S is equal to sum of product of G and E and C, which will lead to the introduction of distortion in the range from -G to G for any value key. Thus, the proposed technique through the use of described rule makes it possible to simultaneously hide a block of hidden information bits, and the cover file distortion will be the same as in the known method for key is equal to 1. In the general case, the amount of introduced distortion in the proposed method will be determined only by the gain coefficient G and will not depend on key. So from the encoding density of the steganographic system. This is the main advantage of the proposed method. To restore each block of information message on the receiving side, it is necessary to determine the number of the spreading sequence phi. To do this, it is proposed to alternately calculate the correlation coefficients rho for all L from 0 to n-1, the address L sequence number of the discrete signal phi for which the calculated correlation coefficient rho will be maximum, sets the decimal value of the information message block, which was hidden on the transmitting side. So let's formalize the process described above. To restore the block of the hidden message M, we use a correlation receiver, the rule of which is to calculate the correlation coefficient ρ according to the following rule. Taking assumption that correlation of phi and S is approximately equal to the following, and that correlation of phi L and phi M is approximately equal to 0, we have possible values of the correlation of phi L and C. So it is equal to 0 when L isn't equal to m with index e, and it is equal to g if L is equal to m with index e. According to this, the value of the information message block m with index e is determined by the rule of maximum value of correlation coefficient of phi L and C. Thus, to restore each block m with index e of information message, it is necessary to calculate no more than 2 by key correlation coefficients row and select the maximum value. The index L of such pseudorandom sequence f sets the block value m with index e. Obviously, while increasing the block size, the computational complexity of recovering a message rapidly increases. This is the main disadvantage of our method. For example, as the next step, let's make an overview of the results of experimental studies according to the proposed method. To assess the quality of cover files, signal-to-noise ratios are usually used. For example, the peak signal-to-noise ratio (PSNR) is the ratio between the maximum possible signal power and the power of the distorting noise. For convenience, PSNR is usually expressed on a logarithmic scale. For monochrome images, this peak signal-to-noise ratio is calculated from the mean squared error (MSE). For example, for a monochrome image with size of product of n with index 1 to n with index 2, and it is distorted by approximation errors C S. This value is determined by the following formula. C and S with indexes in such case are pixel brightness values with coordinates I and For our experiments, we used a standard test image of Lena, encoding each monochrome half-tone pixel with 1 byte. In figure from 2 to 5 show samples of appropriate cover images when hiding informational message using rule with G is equal to 4. As we can see, using the proposed method, we were able to convert an image with almost indistinguishable distortion comparable to the conversion according to the known method. It should be noted that let's look to the values of the mean squared error for various values g. By analyzing the above-mentioned results, the proposed method can significantly reduce the distortion of the cover file. A further increase in the value doesn't lead to a decrease in the quality of cover images, and this figure clearly confirms this. In the figure 8, PSNR graph is presented. So we can note that increasing in the number when using the well-known rule leads to an inevitable decrease in the image quality. As conclusions, we can argue that direct split spectrum technology is successfully applied in steganographic problems. With the use of expanded pseudorandom sequence, it is possible to reliably hide information messages in cover files. However, in this case, natural contradictions arise. For increasing in the amount of hidden data leads to a decrease in the quality of cover files, for example, images. For reducing the error rate in recovered message, it is necessary to increase the stego power, which further distorts cover files. We have proposed a new information hiding techniques based on the addressing of the pseudorandom sequence. This method leads to the increase in computational complexity. It is necessary to repeatedly calculate the correlation coefficients with all possible values to recover messages. However, the quality of cover files is practically not reduced. Our experiments have shown that split-spectrum steganography technique indeed reduces the distortion in color images compared to other techniques. Thank you for your attention.